Hello 108 students, Mr. McCue here. We're back on section 10.2. We're going to keep working on exponential functions. We're going to do some solving of exponential equations here, and of course we're going to work on page 3 of our class notes. Okay, now this new concept we're working on here now is basically taking the fact that if you have the same base on the left hand right hand side of the equation, that when you have that condition happening, that forces that the exponents have to be true to make the equality happen. Okay, and so what I have here in my notes is to say when the bases are the same, then set the exponents equal to each other, and this is all true except for the case when the base equals 1, and that's because you could have 1 to the third equals 1 to the fourth, and that's going to be a true statement, so there's no need to follow that. Okay, so we are working on objective 3 here, and we'll go ahead and try to work an example here. What we want to take into account is if you have 4 steps to process through on these type of problems. Wanted to get to a situation where each side of the equation must have the same base. We'll have to do a little bit of manipulating on that when we do some of the problems, but you want to express each base as a power of the same base if possible. If you can't do that, then you can't solve these. Number 2, simplify the exponents by using the rule of exponents. I think when I work through the example you'll see what I mean there. You're going to use the power rule to do that. Step 3 says set the exponents equal to each other now that you know you have the exact same base. Now that is a new concept. When I work this through, be prepared to see that the bases are just going to be left alone, because then you're going to focus on the exponents. And finally, solve the equation from step 3. Okay, so let's go ahead and take a look at example 4. We have 9 raised to the x equals 27. Okay, now what you want to do here is you've got to realize that the exponent is up in, the variable x is up in the exponent. That causes you to say, I got to figure out how to come up with the same base. And I'm going to look at the 9 and say, can I come up with, think of squaring or cubing, and what could 9 be replaced with? And what comes to my mind is I could take 3 squared is equivalent to 9. And so I put that in there with the parentheses, and I show the outside or super exponent as an x. Next I come over and I look at 27, and it triggers in my mind that if I had a base of 3, could I come up with a base of 3 on the right hand side? And then I kind of remember that 3 cubed is 27. Usually in these problems they will pick numbers that are fairly easy to kind of figure out how you got to arrange or situate so that you've got the same base. And then once you realize you have the same base, the next step here on step simplify the exponents from rule 2 using the rules of exponent, which means the power rule, is to say when you have an inside exponent and an outside exponent, you're going to go ahead and multiply because of the parentheses, and you're going to write 3 raised to 2 times x, or 2x. Okay, once you've done that statement, you notice I've got the 2 underlines here. You have identified the exact same base. Now what you do is you forget about the bases and you drop the exponent down. 2x equals 3, and you go ahead and solve it. This step right here is a little new to us. We're not used to just dropping the bases, but that's because the bases are the same, that causes the exponents have to be equal to the same. So now you take 2x, set it equal to 3, divide both sides by 2, and lo and behold, you've got x equals 3/2. And there's your first answer. Okay, we can work one more here. Example 5, I squeezed it in on our notes. I look at this problem and I see that I have 4 as the base raised to the 3x minus 1. Again, your variable is up in the exponent. I see 16 as the base raised to the x plus 2. Focus on the bases, and I see the 4 and I see 16, and what triggers in my mind is I could replace 16 with 4 squared. Again, usually on these your square and your cubes will help you out. Now that I've done that, I notice I do have the same base. I got one little detail I need to work with. I still got these parentheses. I got the inside exponent. I got the new outside super exponent, which is x plus 2, which I dropped down. And now I need to do the distributive property. I'm going to take 2 times x, 2 times 2, and replace the parentheses. They go away with 4 raised to 2x plus 4. Now finally, without any question, there's the 4 as the base, there's the 4 as the base, there's no parentheses. Now you drop the exponent expression down and you isolate it. Excuse me, wouldn't isolate, but you solve for x now. Now here I'm trying to show the 2 for 1 special. I see 3x on the left, 2x on the right. I'm going to minus 2x on both sides. The variable x will be on the left hand side, so I'll add 1 to both sides, bringing me over to on the next page. Well, excuse me, not next page, but over here on step 4. Might want to add all these up. 3x minus 2x is x. There's a 0. There's a 0. 4 plus 1 is 5. And there's your solution. So it's just like we have over here. Okay, well, that does it for page 3. We're moving along here, so I'll say goodbye now, and I'll see you on the next video for page 4.